And then this is interesting statistics. You can see the data sets like year wise, what are the models like. You see, since 1993, here it started 1993, it was Pen Tree Bank took almost 1 million tokens. And then in 2011, there is a huge gap. If you see between 1993 here, 1993 to 2011 almost. If you see the next model dataset, it's actually text 8. It came in 2011. It took almost 17 million tokens. And then the next dataset model is the 1 billion, which is launched in 2013, where you can see the drastic change from 17 to 800 million. And then book corpus in 2015, you see 985. And then GPT-2 OpenAI, that's where the trend setter, like 2009, if you see 10,000 models. And then GTP3 open, this is also OpenAI, but 2020, we can see from 10,000 to almost half a million, 500,000 million tokens. Then imagine how you can see the trend here from 1993 to 2020. And then more data generically needs more compute. Like you need a more, if you need more data, then it needs to be computed in more ways. Actually, the amount of compute used in the largest AI training runs has doubled every 3.5 months. Every 3.5 months, the amount of data getting doubled. You can see the graph there from 2013, 14, 15. It drastically doubled actually every 3.5 months. So that's where you can see the graph here. So moving on to the next thing, let's see what a language model trained on 500 billion tokens can do. Let's see. It's interesting. Okay. So before going that, like let's see what data is gaining actually. Then we can dive into the machine learning design. So the first thing is the very basic thing. This is the basic thing. It could be something basic thing, but just let's walk through this also. So data basics first. Let's see the data basics, data sources. So what is that actually? Like user generated, it could be user generated inputs and clicks, anything. It could be any source of data. And then it could be even system generated, logs, metadata, predictions, and then enterprise application data. It's like inventory, customer relationship, could be anything like from the applications. And then the last one is the third party data. So you cannot, these first three things you can predict it. The last one you cannot predict. It could be any form or any format. It could come from the third party system. So we can see the, you can see the detailed way like how the third party data is creepy, but it's fascinating. Types of data you can see like it could be from social media, income, job portal, it could be online portal, it could be e-commerce data, anything. And then second group of data is democratic group, like demographic group. So where you can see the group it by gender, age, work in tech, something like that. And then more available with mobile advertiser id. And then the last group is useful for learning features, people like who like A also be like B, something like that. So this is where like the third party data where it could be creeping, but it's actually fascinating. So let's go next part, like how format and store it actually, like how to store both data and labels. That's the important thing. Like we have the data, we have a label. So how we are going to store both the things? That's going to be challenge. And then how to store a model, how to store any complex object. So these three things are the basic things we need to know. So let's see, after converting a data structure or object state into format that can be stored or transmitted and reconstructed later. So that's where that's the thing. Like in this table, you can see like what are the format data formats, and then what is what is their binary text, and this is human readable or like that we can see, and then we can see an example also there. Like example, if you see a JSON format where it is a text and then it's a human readable, yes, and then use cases everywhere. Like you cannot avoid this JSON format. Like it's there in everywhere, every field. every ETL model you will see this data type. CSV, of course, I've no need to say that. You will not, you will see like it's very commonly used data format. And then parakeet, avro, protobuf, pickle, like you can see like lot of type of formats, data formats. So the next one you see is the column based and then row based. You can see the table. I just put it in the detail way. Like you can see the, we can see it could be either column based or it could be row based. If you see the column based, stored and retrieved column by column, and then good for accessing features also. But in the row based, stored and retrieved row by row. So that's what the main difference actually. You can see there by column by column. Here you can see retrieve the data row by row. It's also good for accessing samples. So then we compare the text versus the binary file. This is also interesting area. You can see the benefits of what is the column based, and then you can see what is actually now text versus binary files. Flexible data access can access only columns required. Example, if your data has like let's say 1,000 columns and you only want 5 columns, so load only 5 columns. That's it. So and then column based, stored and retrieve column by column, good for accessing features. That's what we discussed in the previous slide, right? You can unload the result of an Amazon Redshift query to your Amazon 3 like S3 data like Apache, Paraquet, and efficient open columnar storage format for analytics. So this is the thing. So the one at the bottom it's mentioned about the Amazon Redshift actually, and then the Pandas data frame. This is interesting trending thing. You can see here column. It's a column based accessing a row much slower than accessing a column and NumPy. And then NumPy render row based by default. It comes actually by row based by default. You can see the sample algorithms there. So we can see the comparison here by text files and the binary files. Example is CSV, then there is binary files a parakeet, and then prose. What is the prose? It's actually human readable. We know, right? Like CSV JSON, it's actually human readable, but binary files are compact. It's not. You cannot just go and we cannot. No one can just like that go and read the files. To store the number like this many, like so let's say 1 million or 1 billion, its maximum supported is 7 characters, but it's stored in the binary files can go like in 32 only 4 bytes. So the next one is good for managing transaction. We are seeing this column based row based, right? The last one is good for managing transaction as they come in. And then column based, if you see, good for using data analytics task. Like this is the map for column based analytic task is key, and for the row based transaction based. And then this next interesting thing is the OLTP versus OLAP. So most of our industries people here on the conference, so you guys will be familiar that about the online transaction and then analytic processing transaction. So that one we will see here now. So online transaction processing, how to handle a large number of small transactions, and then requirements, operations. So these three things are key for OLTP. For example, ordering food, ordering rides, buying things online, transferring money. So these are the things how to handle number of small transactions. So requirement here, if you see, it could be atomicity, isolation, and fast response time. And then the operations you see, just insert, update, delete. That's it. Could be any of these operations. On the other hand, if you see the OLAP, like online analytic processing method, how to get these are the another three things. How to get aggregated information from a large amount of data, and then the requirements can handle complex queries on large volumes. And then the last one is operation. It will be mostly select. We're not going to update or insert doing anything. Just going to be select. You can just see the